This is video 14.5 in our first Principles of Astrophotography series. In this video we discuss binning, which is a technique for increasing the signal-to-noise ratio at the expense of resolution.
Revolution!
It's going to be a revolution. This video is based on section 14.5 of our first Principles of Astrophotography book, which is linked in the description below.
I'm Ren Edwards.
And I'm Boyd Edwards.
Let's talk sensor sensibility. Binning is the process of combining pixels into larger pixels to increase the signal-to-noise ratio at the expense, and it's not a small expense, of resolution.
Okay, so this square grid that's black is the original grid. So there's 1, 2, 3, 4 pixels in that black square grid. And the pixel size is denoted here by capital P. And let's just take a particular example, the ASI 585 camera by ZWO. It has 3,840 pixels by 2160 pixels, and its pixel size is 2.9 microns. So now suppose that we wanted to bin with that camera. What we're going to do is to replace those 4 pixels with a single pixel that's twice the width and twice the height. So we take those 4 pixels and combine it into one.
Well, it's essentially summing the values of all 4 pixels.
Or averaging probably, but yeah. And you can actually bin while you're shooting the objects, or you can bin in post-processing. You can do it in PixInsight.
Oh, yeah.
I'm pretty sure.
Probably.
You've probably never tried it.
Never done it.
And if you don't like your image and there's a lot of noise in it, for example, then try binning it and see if you like that. But the bottom line is that once you replace those 4 pixels with a single pixel, the size of that pixel is going to be double the size, and that's denoted here by P prime. So you take 2 times 2.9 and you get 5.8. The signal-to-noise ratio is proportional to the pixel size. So the original image, you'd put in 2.9 microns in here for P, and in the binned image you put 5.8. So you've just, by binning, you've doubled the signal-to-noise ratio. It just occurs to me that binning would be a good idea when you're oversampled.
Oh, absolutely.
Right?
Yeah, I never thought about that, yeah.
Oversampling means you've got too many pixels in the image. You're wasting pixels on the sky. There are more pixels than you can actually capture detail in the sky.
Your camera telescope combination cannot distinguish all the pixels. Yeah.
And so in a case like that, you bin it and you get a better signal-to-noise ratio, and you really don't lose much resolution because you didn't have it in the first place.
Right.
Because you're oversampled. Yeah, that's binning. A lot of people use it, and we may someday use it.
I think it's also important to note you're 1/4 the number of pixels, so you're far.
Your file sizes are smaller.
Well,
your processing is easier.
That's true. It may be easier, but your resolution is smaller.
Oh, yeah.
Your total resolution is
you're not going to see as much detail.
Your detail,
especially if you're well sampled and you've got plenty of time on target. But again, if you had one clear night and you're talking about a really dim object, and then the next 3 months are cloudy, then maybe you bin it to get as much.
Maybe in Peru that happens. But
maybe in Peru.
Well, I guess Utah happens too.
Yeah.
But
well,
there's a place for it, I'm sure. And we'll probably get to that place eventually. But
thanks for watching.
We'll see you next time.